Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Second of the three talks. Paulo Marquez is going to give a talk on the RAIL2 Runtime Assembly Instrumentation Library. This is a continuation of work that started in the first rotor RFP process, so it represents some substantial amount of investment in engineering and understanding of rotor. The work has been supported also by Bruno Cabral, who I was fortunate to have join me on a rotor workshop that I hosted in South America this year, and he made a presentation. So, by way of introduction, Paulo is assistant professor at the University of Coimbra. Is that correct?
Yes.
Coimbra, in Portugal, and a researcher at the Dependable Systems Group. His current research interests are connected to reflective middleware infrastructures, dynamic reconfiguration, and distributed programming. He's the author of a well-known book on the C# programming language and the .NET platform. He leads the RAIL project on code instrumentation. Bruno is a PhD candidate under Paulo. He is working on code instrumentation and its uses in building systems that are more robust to errors and less error-prone to program. He was the main implementer of the RAIL software package for code instrumentation, which is the basis for his master's dissertation.
Okay, thank you. As Mark has told you, I'm going to talk to you about RAIL. This is a library for code instrumentation in .NET. And this was supported by 2 research grants from Microsoft. And actually, as Mark told you, Bruno was the main implementer of the system, and I have been leading the project until now. So let me start by telling you about code instrumentation. What is code instrumentation and how it can be used to perform operations on code. Basically, code instrumentation is the ability to change code after you have a binary file. So you have a binary file and you want to perform some kind of modifications like change classes or code or copy classes from one point to another. And basically this is the meaning of code instrumentation. And if you think about it, you have several possible application scenarios. If you are able to do code instrumentation, you can perform security verifications on the code. You can create dynamic code optimizers. For instance, if you detect that you have a certain path of code that is executed repeatedly and it's always jumping across certain boundaries, then at runtime you can grab all this code, put it in a straight line, and have an optimized line of code. You can do profiling, so you can dynamically insert profiling instructions. You can do fault injection for doing reliability evaluation. If you think about it, most of the code today is based on components. So if you want to evaluate the reliability of your software, you can, for instance, inject the fault in one of the components and see how the rest of the system reacts. And if you do this in turn for each one of the components, you get an idea of the reliability of the whole software package that you are using. You can do aspect-oriented programming. You can do a lot of things. So what is this RAIL library anyway? RAIL is a library that allows you to modify bytecode from the common language runtime. So basically you have a framework where you can modify the assemblies that you have in .NET. And actually we are not just targeting the rotor platform, we are generically targeting the whole common language infrastructure as is available on the commercial implementation of .NET. So let me give you a simple example. Imagine that you have downloaded an application from the internet. And if you think about it, you don't know who has written the application, if the application is going to read your files in the disk and send some information to the internet, and so on. It is true that you have some mechanisms like access control lists and so on, and you can selectively give permissions to the application. But actually, the framework that you have in terms of security is something like everything or nothing. If the application asks you for a certain permission, either you give that permission or you don't. But if you don't, you are not able to run the application. So one very nice example on how you can use code instrumentation in this type of scenarios is that you can grab one of these code instrumentation libraries like RAIL and perform some modifications on the binary that you have. For instance, imagine that you have downloaded this application, and this application is performing something in your disk like accessing some secret file. And using a code instrumentation library like RAIL, you can ask the library to find all the instances of a file reference and change it to something that I will call secure file access. And actually, this secure file access is nothing more than a proxy. So basically, if you create a proxy file, you can encapsulate the real reference to the file here, and actually you can perform some kind of security verifications or inform the user that the application is trying to access a certain file and ask if it is allowed to proceed with that access or not. So just for you to get an idea on how this works with RAIL, the idea is that in this case, the programmer writes some code like this. So basically, you have an API that allows you to open an assembly or read an assembly. And what this does is to construct a representation of the assembly in memory. And then you can ask RAIL to define a reference to file. This is the original. This is the original references, the original types that you had in your binary file, and then you can get a reference to the new secure file access type, and then you can create something called a reference replacer that allows you to walk over all the binary code and to perform a certain operation. In this case, we have a visitor pattern that, given an assembly, allows you to accept the transformations using this replacer. So basically, the RAIL framework in this case will grab your assembly, and using this replacer will traverse all the code that is inside the original file, the original binary, and replace all the references from file to secure file access, allowing you to have some kind of security and checks in this case. And what the RAIL library has is all kinds of constructs that allow you to do manipulations in binary code. Another interesting thing is that in this case we are working with an assembly, but actually you can have modules, you can have substitutions only in certain classes or of certain methods and so on. So it's a complete framework for doing code instrumentation. So if you look at the way that you do this kind of modifications, you start with a binary file that you can load into the RAIL framework. And actually what the RAIL framework does is to collect all the information in an object-oriented way, representing the full information inside of the assembly. The programmer then is able to specify the kind of transformations that he wants to do to the code and actually create a new assembly with the results. After that, either the assembly is executed in memory or you can save it to disk. Actually, the system has evolved a lot since these times, and nowadays we are able to actually do injection of source code here instead of just manipulating assemblies. And actually, we are a little bit more flexible than this. We support some kind of runtime modifications. So we are able to proxy certain classes and actually change things like references at runtime. So if you look at the normal architecture on how you do these kind of things, you have the source code of the original files, which are compiled into a binary file, a P executable. And actually what Rail does is to intercept this loading module and actually inspect what's inside of the binary file and create you a representation of this. So currently, what can you do with Rail? Actually, you can iterate over code, you can inject and remove instructions. Rail does all the calculations necessary in terms of jumps and so on, so that everything is quite easy for the programmer. You can replace type references. You can add epilogues and prologues to methods. You can redirect method accesses, field access, and so on. You can actually manipulate custom attributes. You can copy-paste types, methods, and code across assemblies. You can manipulate exception blocks. And most recently, we have integrated the library with code DOM. So actually, you don't have to always use binary code, but you can actually inject code at the source level for doing these kind of things. I will show you an example of this later on. If you look at an assembly which has all the metadata and all the code for the methods and all the native image sections, what Rail is actually doing is creating an object-oriented representation for whatever is inside of the binary code, so that the programmer can manipulate this structure at any level that he wants. In terms of the internal structure of Rail, basically, you have a low-level library that allows you to read the assemblies into memory. This is kind of a low-level representation where you still see the things in terms of, raw data. And the main part of Rail is actually this part here. So you have three major modules. You have a module that allows you to represent all the data inside of an assembly. Basically, this module here represents the object-oriented way of seeing an assembly that you can observe in this slide. Then you have another module that allows you to represent EL instructions. So you have several type of EL instructions, and all this is also represented in an object-oriented way. And then you have the high-level instrumentation classes. These are the classes that actually allow you to do the modifications to the binary files. And after you have defined the modifications that you want using this module that is actually manipulating a tree-like structure with using these classes, and if you are manipulating code is actually using these classes. When you are ready to create a new assembly with those modifications, basically you can pass it to a library that will create the final binary, the final assembly, either in memory or in disk. Currently, the library available is using reflection emit, but you can use other libraries. One of the features that was implemented in the new library, the RAIL2 library, is that both the reading and the writing infrastructure are completely configurable. So we have created an abstraction layer for reading and writing files. And actually, in this image, you can see that we are using the PE toolkit. Actually, today we are using Cecil, also from Mono. And you can change these libraries as you want. Another new feature that we have in the system is that we have integrated this with CodeOM. So instead of just reading binary code and assemblies at a low level, you can read an assembly and inject some code at source level, and these two things will integrate together. Let me show you an example of this. Going back to the previous example, if you think about the proxy file class, the secure file access, nowadays it's actually possible to specify the code inside of a string and actually create an assembly in memory using this string that defines the code, and then doing all this kind of reference replacement or code injection directly. So nowadays, RAIL is quite flexible. You can work with binary code only and everything has been precompiled, or you can actually inject code at runtime and generate these things at runtime. To conclude, basically, RAIL is a library for code instrumentation in .NET. It provides you a high level of abstraction. So you have all these code instrumentation patterns that allow you to do code instrumentation without looking into the fine details of metadata and binary files and so on. And actually, you don't need to manipulate EL code directly. But actually, if you want to do that, you actually can do that. You can manipulate EL code directly. We have a very flexible way of handling EL instructions. Basically, if you want to represent instructions, we have a factory of instructions that allow you to directly create instructions using different parameters. And in a sense, it's a little bit like a type-safe way of creating EL instructions. Everything is represented in an object-oriented way using a number of classes that we have defined. This is quite different from some code instrumentation classes, some code instrumentation libraries that are available that allow you to see the inside of the binary files, but in a very low level kind of way. In this case, in the case of the RAIL library, you have quite a nice object-oriented framework to do this kind of modifications. We do extensive use of design patterns, so we have factories for several kind of for creating instructions. We use visitors for traversing trees and so on. And actually, this is quite interesting because when we started, there wasn't many code instrumentation libraries available for .NET. There was the abstract EL library from Donsheim in Cambridge, and nothing much to go on. And actually, over time, a lot of people started to use this library, and actually, we have spent a lot of time just correcting bugs and implementing features that people asked us about. And for instance, since, well, the project has been running for more or less 2 years now, but during the last year we had about 30 downloads of the binary files of the library each month, 20, 30, which I think it's quite good. So I'm open to questions. If you like to learn more, you can take a look at these 2 papers and go ahead. Yeah.
If I understand correctly, you for just direct manipulation of bits of B files like arrays and so on, you're using some library or some namespace from Mono, yes?
Yes, yeah. Actually, in the beginning, we had implemented our own library, but the problem is that dealing with B files is quite messy. So actually, things would be working, and then they would crash, and then we would correct the problems and so on. And we had a lot of iterations in this kind of work. And at a certain point, we just said, OK, we don't want to care about this, and started to use a certain library, and then that library would not work again, and we changed libraries and so on. And this was happening so many times that we actually decided to create an abstraction layer and say, OK, we will use the best library that is available. When it's necessary to change libraries, we just re-implement this abstraction layer, and let's focus on the high-level instrumentation patterns that we want to implement. So actually, in this picture, I've shown you MonoPE toolkit, but actually we are now using MonoCecil and not MonoPE toolkit. Any more questions? Yeah.
What are the applications you have really tried out using this?
Well, we had, not really. We had been focused more on the implementation of the library than using the library. But there are many projects using this library. There are toolkits for aspect-oriented programming that are using our library. There are some projects that are trying to integrate remoting capabilities in AFOL, I think, using our library. And several projects are actually using this, but we have been focusing more on the implementation of the library and not so much on using it. Okay.